This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
What is some of your vision as an engineer for incorporating some of these innovations coming out of Tallwood into real buildings? Like, where are you seeing some progress, and what are some challenges? Some future research questions.
Yeah, right. Yeah, so let's stay positive. We won't start with the challenges. We'll start with sort of what I see some of these innovations where they might translate to in practice. I think right now there's this great how do you say it? Sort of like there's this great like intersection of two movements happening. The mass timber movement, which sort of started in the Pacific Northwest, but I guess in the U.S. has started in the Pacific Northwest, but really started in Europe, and has grown to be nationwide, and obviously transcends borders. And the embodied carbon, global warming potential, and I'd even throw resilience into kind of in these movements. They dovetail quite well. They're very synergistic. And I think that's really where I see the progress, the likelihood of this sort of all of us coming together. Sort of what's the saying? Rising tide lifts all ships.
Raises all boats. Yeah,
raises all boats. Yeah, exactly. I think that if we can recognize the co-benefits of a resilient seismic force resisting system, building out of wood for aesthetics and the human experience in the buildings, and the benefit to our climate and to potential climate collapse, I think that's really powerful. And that's my, I guess I would say, that's my sliver of optimism. I'm not generally fully an optimistic person, but that's my sliver of optimism that we can kind of see many of these movements come together toward a common goal.
Yeah, it's in this space. It's good to be an optimistic realist, right?
Yes, exactly.
Have hope for the future, yes. Grounded in reality.
Yes, grounded in reality. Absolutely. I think the thing that engineers to a degree, and we'll just skim right close to what some of the challenges are. But engineers have a lot of limitations put in front of us, right, when we're doing design for real building projects. And we have a sort of like, I won't say, the common analogy, we use another analogy, is tools in the tool belt, right? And I'll say, okay, here's me going back to my same analogy over again, but I think it's more about it's about spices, right? What spices you have available to you.
There you go.
And right now, some of those spices are on the top shelf, right? They are out of reach for a lot of engineers. They're out of reach for a lot of owners. Really, they're accessed through performance-based design, right? If you need to use a mass timber rocking wall system right now, you're going down the path of performance-based design, which has great applications, it works, but it's for the few, right? It's not for the masses. And so what I'd like to see, and what I'm encouraged to see with the innovations coming out of Tallwood research, is how we can take that, basically the use or application of a mass timber rock and roll building, and bring it to everyone, in a way so we can start to see real buildings built this way and for the right application, right? This is not the seismic force resisting system to end all seismic force resisting systems.
Yes,
it's just one that we need to have available to us. For the right application, I think that we can do that through a lot of the work that's being done with the 10-story test.
Yeah, it's especially encouraging to see. I mean, now that we live in the Pacific Northwest, when Tallwood started, I lived in Indiana, which was really interesting. But now it's staring you in the face, yes, living in Eugene, we probably won't be as impacted by the big one as other areas of the Pacific Northwest will be. But it's on my mind, right? Of wow, our little house here, if it were closer to the coast, we'd be in real trouble, and would be looking actively at these seismic retrofits that are coming out of things like Tallwood, things like the Tallwood Design Institute writ large, which if you're interested in this at all listening, check out the resources there at TDI. And their conference is excellent and very affordable. I mean, just drove up to Corvallis and there's a couple $100. It's not a insurmountable way to rub elbows with the leading people who are doing the research and putting it into practice of mass timber, and see how it's going to apply to places like your neighborhood or the architecture of a elevated structure in your city in the not too distant future. It's really cool.
I think, I mean, you bring up great points, and that's what I was maybe not doing as well to say earlier, is that
this is why I'm here.
A lot of times we have these, like on projects, they're like visioning, as part of the visioning exercise, we have objectives, and a lot of times those objectives begin to compete against each other. So like resilience and sustainability, right, can often compete against each other. What I see the real advantage of the Tallwood research is that we can basically turn those from being working against each other to working with each other, right? So that there's something that is less bad for the climate, can be resilient and sustainable, kind of all at the same time.
And even more so, good for us as humans on a psychological level, right? Like being around beautiful design with natural materials, in our field of vision is just good for our, us sociologically and mentally too.
Absolutely. I mean, like during this was my pandemic background that you're seeing behind me, and I'm not sure this was the thing that got me through it. Maybe it was alcohol, but it was one of the two that like made me, being around wood is a calming experience, and that shouldn't be downplayed.
Yeah, and any way we can make it more available to more people through building apartment buildings that are seismically resilient, sustainable, beautiful, awesome. Or building furniture out of the offcuts from those, like one of our colleagues at the University of Oregon is doing. It's so cool. So anyway, it's amazing to see some of these applications from this building project that are going to be coming out for decades. We've got great ways of reusing that data and seeing it come along. So really, really excited to explore this. And thanks for coming today, Reid. It's been great to get a little bit of your perspective, and hopefully I'll see you down in San Diego in March if all goes well.
Yes.
Knocking on all the wood we have available here.
Literally knocking on wood. Yes. It doesn't hurt that the test is happening in San Diego in the spring in the Pacific Northwest. Gives a good excuse to escape the rain for a few days.
Boy, do we need some sun as I am experiencing some for once, but yes. So thanks so much, Reid, and we'll hopefully see you down in San Diego in the not too distant future. Thank you so much for listening to this episode of Design Safe Radio. We really appreciate it. Smash that like button if you're watching this on YouTube. Hit that little subscribe button. That really helps us out and bring this message to more people who are interested in hearing about how our engineers and scientists are making our society more resilient to everything nature throws at us. A big thank you to our sponsors at the National Science Foundation. Our award number is 212-9782. And a big thank you to our program officer, Joy Kowski, who is excellent. And our team at the National Science Foundation's Network Coordination Office for NARI. Marty LaChance is our question writer and copy editor extraordinaire. Raquel Ruiz manages all things technical and editorial. And Morgan Glass is our social media coordinator. Big thank you to everybody at the NARI NCO and all of our experimental facilities. Thank you and have a great day.